does the internal energy depend more strongly on volume or temperature? For ideal gases, the internal energy U only depends on temperature. It does not depend on volume at all. However, for real gases, James Joule showed that internal energy does depend on volume. Delta U over delta V is non-zero for real gases, but this is fairly small. For liquids and solids, besides gases, we have this equation here. U depends on temperature and volume. This is a very general equation. And over here, delta U over delta T under constant volume condition is simply the isochoric heat capacity. And over here, this part, delta U over delta V, when temperature is constant, it's called internal pressure. The expression of this is T delta P over delta T under constant volume condition minus P. We will be able to derive this equals this after chapter 6. For a van der Waals gas, we say du equals Cv dt plus An squared over V squared dV, because we proved this part is simply An squared over V squared. How can we compute the internal energy change if the volume and temperature of a van der Waals gas both change? Very simple. We integrate both sides. Then delta U is simply the integral of Cv dt plus the integral of An squared over V squared dV. So over here, you just need to know the value of Cv. Over here, well, it's very easy to integrate dV over V squared. It's negative 1 over V. So this part is simply An squared times negative 1 over V. And then you just plug in the lower and upper limits of the integral. In summary, U depends more on temperature for all cases. For ideal gas, U does not depend on volume at all. Internal energy only depends on temperature. For real gas, U does depend on the volume, but this dependence is very small. Finally, for liquids and solids, actually delta U depends on volume significantly. So try to compress the volume of a liquid or a solid. You need a lot of energy. But because the volume change of a solid or a liquid is so small, if you integrate this part, despite the fact that delta U over delta V is large, if Vi and Vf are very close to each other, and that's normally the case for a liquid or solid, and then this integral is still smaller than the internal energy change caused by temperature change. So even for liquids and solids, the internal energy depends more on temperature, only because the volume change of a liquid or solid is negligible.